pressure transducer, where we measure the pressure after and before the pump. So that's how you're going to get your pressure rise across the pump. Through this valve, this is what you can use to control just the flow rate through the system. And today we're going to do it manual. It's got a control system, but it needs some tweaking. I think the dead zone isn't large enough, so if you tell it like 50 gallons per minute and it goes to 52 and 47 and 52 and 47, it just keeps going back and forth. So we don't mess with that. So you can just manually open and close this valve. Magnetic flow meter, very accurate, precise way to measure flow rate. Then it goes through this manifold, so when you're doing the pump, it's just going to go through that bottom that's like a bypass. And then when you're measuring for the head loss and flow coefficient of the valve, you'll close this and you'll route through this valve, this valve, this valve. I think this is a butterfly valve. One of these is a gate valve, one of these is a globe valve, even though they look almost identical. You can get the numbers off of them and figure out what they are. They're on here. Oh, actually this says, this is the gate valve.
Do you still need this, Professor?
No, you can take it down. Yeah, I think. And this is the, probably this is the globe valve, I think. Oh yeah, globe valve. One thing about these, we'll measure the pressure right here and the pressure under there. And so when you try to isolate, say to get the pressure drop through this gate valve, you know, the flow is going to come in here. Basically treat this like an elbow. It's going to come up here, go here, it's going to go way down, it's going to go through there. So you want to sort of subtract out the pressure loss through each of these things in order to, you know, isolate just the pressure loss across this. So there's that part of it.
Do you have to account for that straight coupling there?
No, I would just treat this like a straight run of pipe. Okay. Treat this like an elbow. Yeah.
Do you have a schematic of these measurements, or do
I don't. We have a tape measure though.
Okay.
So I don't. All right. So there's that part of it, and for that I just control the flow rate with this. The things you can look at. So you'll have flow rate overall, and then you'll also have, this is the pressure difference across, you know, from that pressure transducer to this pressure transducer. So you'll have that one, yeah, the very bottom. Then, flow comes over here. You got 3 flow meters. This is vortex shedding. Yeah, this is the vortex shedding flow meter. This is a turbine flow meter. This is an orifice plate. And so then you can run the flow, you know, through one of these. It'll tell you what the flow rate is over there. You treat the magnetic flow meter like it's the true value, and then you see how these 3 are calibrated. And that's pretty much it. The one thing you might look for, so to get the equivalent length of each of the valves should be no problem. You can do that for any flow rate. One thing you want is the flow coefficient, and that's the flow through the valve when you have 1 psi of pressure drop across it. That's sort of a challenge to get because you have all these other things. So I would just set the flow so that you're a little over 1 psi between those two, and then keep increasing it. So get maybe 4 or 5 points until you get, say, 4 psi through that entire branch. And then from inside there, when you subtract out all the other stuff, you'll see, you know, here it is at 0.7, here it is at 1.5. So we think this is the flow coefficient. So that's the best you can do because we don't have it, you know, measured directly right at the valve. But that's pretty much it. So for the pump curve, you want to do 2 different speeds. So here's a variable frequency drive that changes the speed of the pump. So I'm going to put it at 45 hertz first, and then you can do 60 hertz will be the maximum. So you can see the valves are open, you can hear the water flowing through there. If you look at the screen, it probably tells you what the flow rate is, and the pressure difference across the pump. So I think the valve's pretty much fully open right now. So your flow rate is, let's see, magnetic flow meter, yeah. So it's 110, yeah, you can see the number there. 106, and then here's the pump pressure difference, so it's, what, 13.5 psi. Right now we don't have any sort of file saved, and so you just got to take your data points like by hand. So you just read off of here, get what you think it is, and so here you got one point that's, here's 108 gallons per minute and so many psi, and then you start to close that valve until you get it all the way closed. You should get no flow, and you'd expect that pressure would be higher because now you're on over by the y-axis of that pump curve, as opposed to here's as far to the right on that pump curve as we can get. But that's pretty much it. So somebody move the valve, somebody read these, for this pump part, you just need the pressure across the pump and the flow rate. For the valves, you just need the flow rate and the difference in pressure. And then for these, you just need the flow rate through the magnetic flow meter and the flow rate through this flow meter. Got two different flows. Do you want to record them? I'll record again.
Okay.
Duplicating. Alright? Alright. I'm going to go grab my computer. This valve is a little bit tough to turn. It's not too bad though. Some parts of it gets tough to turn, but when this indicator's at 90 degrees, it's fully open, and then just turn it around so that it gets to 90. Get at least like 10 points in between there. So just move it a little bit, and you'll see the flow change. A little bit, the flow change, and then
Little increments.
Say 10 points, yeah, over to 0. Cool.
Thank you.
I'll be back in 2 minutes.